Hello, welcome to RVB Education.
Video lesson, we are going to find the support reactions of beams subjected to loads. This is a problem statement. We have overhanging beam with hinge support at A and roller support at B. There are several methods to find support reactions of beam. In this problem, the beam reactions are calculated by two methods. One is by using equations of equilibrium and another by using principle of virtual work. First, draw the free body diagram of beam. Since there are no horizontal or inclined forces acts on a beam and no inclined supports, means there is no horizontal or inclined reaction force at hinge support. Here, we need to convert the UDL, that is uniformly distributed load, into an equivalent load which acts at the center of rectangular rod, that is center of UDL. For UDL, the magnitude of the equivalent point load is calculated by using following relation, that is load is equal to perpendicular distance. This is the complete free body diagram of beam. Now, using equations of equilibrium with proper sign convention, we solve step by step. Here, there are no horizontal forces acting on the beam, so it is not necessary to use the horizontal equilibrium equation. The sum of all vertical forces acting on a beam equals to 0. With proper sign convention, the upward forces taken as positive and downward forces taken as a negative. We write this equation. After solving, we get this relation which contain two unknowns. We return to this equation afterwards. To find the unknown force RB, we take the sum of moments about point A. This is the sign convention here we are going to use. The line of action of reactive force RA passes through point A. Hence, do not create a moment. The 40 kN force acting downwards at a distance of 2 meter from point A, which produce clockwise moment about point A. The 10 kN force acting downwards at a distance of 6 meter from point A, which produce clockwise moment about point A. Next, the reactive force RB acting upwards at a distance of 8 meter from point A, which produce counterclockwise moment about point A. Then last one, 20 kN force acting downwards at a distance of 11 meter from point A produce clockwise moment about point A. And write this relation with proper sign convention. After solving all the steps, we get these final answers, and this completes the problem. Now we solve the problem by using virtual work principle. First, draw the free body diagram of a beam. In order to determine the reactive force, first we need to apply a small virtual displacement at the point where support reaction is to be calculated. Consider the other support as the pivot point. Here, assume a small virtual displacement at point B and take point A as the pivot. Then, measure the perpendicular distance of each force from the pivot point and show it in the free body diagram for further calculations. Determine the virtual displacement at every point where a force is applied using the geometry of similar triangles. Corresponding sides have a constant ratio. By using this geometrical property, we find the virtual displacement at each force point. At reactive force RB, we already imagined the virtual displacement delta YB. Then at force 20 kN, by using this similar triangle property, the virtual displacement is L1 by 8 delta YB. In the same way, we find the virtual displacement at each force point. Just see in this table. Now, in the last column, calculate the virtual work by using the relation which is virtual work is equal to force into virtual displacement. While doing this, follow the sign convention that virtual work is positive when the force and virtual displacement act in the same direction, and take it as a negative when they act in a opposite direction. You see here the reactive force RB and displacement at that point is in same direction, hence there is a positive work. And at forces 20 kilonewton, 10 kilonewton, 40 kilonewton, their virtual displacement are in opposite direction. Therefore, their virtual work is negative. You see, the data is presented in tabular form for better understanding. But once you have familiar with the procedure, you can write it directly in the equation form. After written in equation form, we apply the principle of virtual work by equating the algebraic sum of virtual works to be 0. We get the final values here. Now see here, the same procedure is repeated to calculate the reactive force at point A. The complete solution is shown step by step. You can pause the video at any point to follow the calculations carefully. So these are the final support reactions, and with this the problem is completed.
I hope this video lesson helped you to understand the concept. Subscribe to my channel for more lessons. Thank you.